Hello everyone, welcome back to another flipped classroom lesson with Mr. Wagner. Today we're going to be talking about solving equations. We've been doing this in class a lot using the bags of coins and the regular coins to figure out how many are in the bag. And now we want to formalize a lot of that understanding whenever we are using variables and numbers. So let's get started. I want to start talking about something that may seem a little silly, and that's what is an equal sign. You've been using them since first grade, and you probably all assume you understand what an equal sign is, but I just want to make sure you understand it from my perspective. And that's an equal sign is telling us that two things are equivalent. They're the exact same. If they aren't the exact same, we can't use an equal sign. And you'll understand why this is important here in a little bit. So here are some examples of things that are equal. 3 plus 6, you might say, well, that just equals 9. Well, not exactly. It also equals 7 plus 2, which equals 9. 3 plus 6 equals 9. You could say the square root of 81 equals 9. There are many different things that are equivalent to 3 plus 6, and an equal sign will show us that is the case. Here's another example here. All of these are the same. 1 plus 2 plus 3 is the exact same as 2 times 3, which is the same as 6. The equal sign is telling us that all of these are the same or equivalent. And lastly, for your viewing pleasure, people tell me this all the time, particularly students. They tell me I look like the Onceler. So there you go. Laugh, yuck it up, enjoy. All right, so lastly, in class a lot, we've been talking about using a balance because a balance is another implement that tells us that two things are equivalent or the same. If I add a weight to one side of the balance, it's no longer the same, and the balance tells us that. So if I add a weight to one side of the balance, I'm going to have to add the exact same amount of weight to the other side of the balance to get it back to normal. So to keep this balanced, whatever we are doing to one side of an equation, we have to do to the other side. And so that's why I like thinking about balances, because that's true when you use them as well. So let's take this idea and solve some equations. We're going to start out with an easier one, and I want to talk about what are the things that we're trying to do when solving an equation. What is our goal? The goal is to get our unknown, the variable, all on one side. And you'll see why that's important in a minute. Just like when we were doing the bags of coins in class, you should understand why we're trying to get them all on one side. Secondly, we need to get that variable alone. If we have a lot of different weights on a balance, we can't figure out an unknown weight. You have to put it alone on one side of the balance. So here we go. Let's keep this balanced. First off, we're going to get rid of this 12 because we're trying to get the x alone. One idea I've heard in the past to help students with this is that if you don't know to get rid of multiplication first or addition, think of addition and subtraction as an easier bond to break. So this is saying 3 times an unknown number plus 12 equals 27. So we're not going to get rid of that 3 first because the easier bond to break is the addition. So if that helps you remember it, I've heard that before from other teachers, you can use that. So that's what I'm going to do first. I'm going to subtract 12 from this side. And if I do it to the left side of the equation, once again, remember, keep it balanced. I got to do it to the other side. So we'll do this, and those two 12s will go to 0, and the 27 minus 12 equals 15. So right here, you guys probably know the answer already, but I want to get us in the habit of following these steps so that we can find any variable to any equation. So if we have 3 times x equals 15, that means we have to divide by 3 on both sides because we want to do the inverse operation of what is being done to our variable. So if 3 is being multiplied by x, we have to undo that multiplication with division. So if we divide 3 on the left side of the equation, we also have to do it on the right. And finally, we have x all by itself, and it equals 5, because 3 divided by 3 is 1x. So have we met our goal? Have we gotten the variable alone? Yes, we have. That x is all by itself, so we know x equals 5.
Good morning. Please pardon the interruption. At this time, all 11th grade students should report to the theater. All 11th grade students should report to the theater for their class meeting.
In case you didn't hear that, all 11th grade students to the theater for their class meeting. Anyway, moving on. We're going to get to a bit harder equation. This will be the last one we do in this video. And let's see if you can understand why it's a bit harder. Once again, I want to put out our goals so we don't forget. We're getting the variable to one side, and then we have to get the variable alone. And always remember, keep it balanced. So the reason this one's harder, if you remember in class when we're doing the bags of coins, right here we have variables on both sides of the equation. So that's when this first goal, getting the variables to one side, is really important. So we're going to do that first. Right now we have variable x on both sides of the equation. We have 5x and we have 3x. So I'm going to take off the 3x from the right. And I'm just doing that because the 3x is smaller. So when I subtract, it'll make my numbers nice and neat. So if I subtract 3x from one side, I have to subtract it from the other side. Now I see students often just subtract 3 and leave the x. We have to remember these are like terms here, and think of that as like 3 apples or 3 oranges. We're going to be taking them from both sides. So when we do that, we've gotten rid of all the variables on the right side of the equation. So all the variables are on the left now, and that was our first goal. Get the variables to one side. There's no longer an x on the right side of the equation. So what happens now? It's just like our last equation. We want to get rid of that plus 2. So what are we going to do? What's the inverse operation of addition? Well, it's subtraction. So let's subtract 2 from that side. And if we're going to keep it balanced, we got to subtract 2 from the other side. When we do this, now we're left with 2x equals 6. Once again, you're probably at a point where you say, I know that that's 3. I know that 2 times 3 equals 6. And that is great, but we're not always going to have really nice, neat numbers. Sometimes we're going to have fractions or decimals. And so getting in the habit of doing these properly will help us with the harder ones. So how are we going to get rid of that 2 with the x? Well, that means 2 times x, so we have to divide. If we divide by 2, we're left with 1x, and we have to do that on the other side as well. So lastly, we figure out that x equals 3. Have we done what we looked to do? Yes, we got the variable to one side. Yes, we got it alone. There's only 1x there, and we know it equals 3. We talked about in class that you can check your work by plugging that 3 back into our original equation and see if it is in fact the same on both sides. I hope this helped you. I'm going to sign off now because I don't want this to get too long. So thanks for watching.